Hey guys, welcome back to my YouTube channel. So as promised, this is a teaser for the Cape Chemistry Unit 2 classes. There's still space, so you can join. Contact. Welcome back to my YouTube channel. So as promised, I'll be dropping a teaser of my classes every Sunday at 5:30 p.m. So if you know you have a friend doing Cape Chemistry Unit 2, don't be selfish. Tell them that there's a class every Sunday at 5:30 here on this channel, because why you wouldn't tell them? That's not nice. And again, for those of you who aren't following me on Instagram, go over to _CAM_EO. Follow me there and follow me at young_genius.official. So if you are already following me, you have already known, or you already know that I've been showing mad appreciation for all of you who are supporting me over here. All right. And right now, for the class today, nobody showed up. Nobody showed up, so I'll have to reschedule with them, but I cannot delay the post for you guys, so I'll just do the what's next on the syllabus. So I'll show you a screenshot right here. I'll show you what we've covered last week and the week before, and what we'll be covering today. So, I have a habit of chatting you out, but if you want to join the classes, this is the last thing. If you want to join the classes and get the full package is described down below in the description. You can go check it out there. It is 6,000 Jamaican dollars per month, or if you're a non-Jamaican resident, it's 40 US dollars. And you can just message me to work out payment methods and such. I do have PayPal, yeah, and if you don't, we can sort something out. Just message me. So I think that's it. That's all I needed to say. Guys, if you're not subscribed to my channel, just do me a favor. Hit that escape button if you're on full screen. Go down and hit that subscribe button and turn on your post notifications so you know every time I post. Yeah, that's it. Alright, I don't remember if I said this was going to be a short video, but the reason being is empirical formula, or determining empirical formulae and molecular formulae, and the whole combustion analysis aspect of the syllabus, that should have been covered in Unit 1 and the CSEC. So I don't know if this is something I need to stress, but if you think I need to do an extension to this video, just comment down below so I can do that for you guys. Alright, so there are 3 worked examples in the CAPE Unit 2 study guide, and I'll just walk you through how they got the answers that are there, just in case the steps aren't so, how should I say this? You can't follow these steps, or you're having trouble following the steps. Alright, so says calculate the empirical formula. So first of all, that's what we know that we're going to calculate. Let me change that. The empirical formula of a compound of carbon, hydrogen, and iodine. So we know that those are the elements, or the elements that would be in our let's say in our compound, and it says that contains 8.45% carbon, 2.11% hydrogen, and 89.44% iodine. And that's just telling you that, hey, there is more iodine in the compound than carbon and hydrogen, and there's more carbon than hydrogen. Right? If you add up all of these numbers, you should get 100. That is 8.45 plus 2.11 plus 89.44 should give you 100. Alright, so let's do the first part. First of all, these were given in percentages, and you want to turn them into grams, right? And the assumption made is that these percentages were taken from 100 gram of the sample. So 8.45% is the same as 8.45 over 100, and if we multiply that by 100 grams to find out the composition in grams, because remember I said the assumption is it was taken from, or they believe or assume that it's from 100 grams of the sample, then this 100 would cancel this 100, and the 8.545% would indicate that it is 8.445 grams, right? So that's how we get that assumption from all of that. So instead of doing all of this, we can just write the 2.11% as 2.11 grams, seeing that you know that the 100 would cancel the 100 grams and would get 2.11 if we rewrite it like that. So 2.11 over 100, that's 2.11%. Out of 100 grams of a sample would give you 2.11 grams because the unit isn't cancelled out. So let's continue with our work. So what I like to do is write out, I usually just put CH and I, or the symbols for the elements, but so that you can follow, I'll just do the long way right now. So it's carbon, hydrogen, and iodine that is in our sample. And a quick fact, if the question tells you that it's a hydrocarbon, that means that the compound only has carbon and hydrogen, all right? So they won't state that. So since it is 8.45%, that means we have 8.45 grams of carbon, hydrogen is 2.11 grams, and iodine is 89.44 grams. Okay? Now, what we want to do is find out how many moles are in carbon, hydrogen, and iodine. Now, the go-to formula is number of moles is equal to the mass of the substance over the molar mass, right? And in this case, if you can't remember the formula, because for whatever reason, I actually learned it like this, like 1 mole of carbon is equal to 12 grams, right? So some number of moles of carbon will be equal to 8.45 grams. And I work them out like ratios. So I would cross multiply, and that would give me 12 grams multiplied by the unknown number of moles of carbon being equal to 8.45 grams multiplied by 1 mole of carbon, right? Now in math, we easily do the whole divide or multiply on both sides to get rid of something. In this case, we'll divide by 12 grams so that we get this here, the number of moles, the unknown by itself. So yeah, so divide by 12 grams on both sides, and the 12 grams will cancel 12 grams, and we'll end up with the grams canceling the grams. And actually, let me get my calculator. 8.45 over 12, which is the mass of the substance. The 8.45 is actually the mass of the substance over the molar mass, right? It's the same formula. So what I got was, I'm going to write it to 3 decimal places. And that would be the number of moles of carbon being equal to 0.704 moles, because moles is left as or unit. You do the same thing for the working out of hydrogen, but after some practice you'll realize that whatever grams you get for hydrogen is going to always be the number of moles, right? So 1 mole of hydrogen is equal to 1 gram, and that's exactly why. So some number of moles of hydrogen will be equal to 2.11 grams. If we cross multiply, what you'll get is the 1 gram multiplied by the number of moles of hydrogen that we don't know being equal to 2.11 grams multiplied by 1 mole, right? If you divide by 1 gram on both sides, the only thing that will happen is the grams would cancel the grams, and so we'll have the number of moles of hydrogen being equal to 2.11 moles. We'll do the same thing for iodine, where we would say 1 mole of iodine is equal to, here they told you, 127 grams. You should know the first 20 by heart though. It just makes your work a lot easier. And so that would be equal to some number of moles of iodine that we don't know is equal to 89.44 grams. Do the same thing, you cross multiply. I won't write out everything this time though. You'd get 89.44 over 127, and 89.44 divided by 127 is equal to, the number of moles is equal to 0.704. Alright, seeing that we now know the number of moles of carbon, hydrogen, and iodine present in the substance, what we want to do is find out what's the smallest mole value that you got, and in this case it would be 0.704, because 0.704 is way smaller than 2.11, right? Because this here is actually less than 1, this is greater than 1. So yeah, you can figure that out by actually subtracting them from each other. If you get a negative number, you know that, let me show you. If you can't like look at them and know them like that, you can say 0.74 minus 2.11. In this case, you'd get a negative answer, and that would tell you that this is the bigger number. Let me see 0.704 minus 2.11. You would get minus 1.406. The negative sign indicates that the larger number has the negative sign in front of it, right? So yeah, if it were the other way around, let's say 2.11 minus 0.704, you would get 1.406, which would indicate that the larger number is positive, which would mean that the 2.11 here is the larger number. Yeah, so I hope that was clear. So once you have figured out what's the smallest number, you want to divide all of them by the smallest number in order to get the mole ratio. So we'll divide all the numbers by 0.704, 0.704, 0.704, right? This is a given, that's 1 and 1, right? 1, 1. This 2 is 1, 1. So we know that here we have carbon being equal to 1. Hydrogen, we'll come back to that. And iodine being equal to 1 as well. And 2.11 over or divided by 0.704 is 2.9972, which we can easily round up to 3, the nearest whole number. If it were a case where the number ended in 0.25 or 0.25, we could multiply that by 4, right? Numbers that like 0.5, which is a half, you can multiply that by 2, or multiply all the ratios by 2. If one of your numbers ended with 0.25 rather, That's equal to a quarter. So you multiply all your mole ratios by 4, right? So let's say your ratio was being equal to carbon being equal to 1, hydrogen being equal to 2.25, and iodine being equal to 1 as well. 0.25 is the same as a quarter, so you can multiply everything, all of these, by 4. So carbon will then be equal to 4, hydrogen be equal to 9, and iodine be equal to 4, right? Let's say the values that you got were carbon being equal to 1, hydrogen being equal to 2.5, iodine 1. You can multiply all of these by 2 because 0.5 is the same as a half. So then you would get carbon being equal to 2. That's terrible. Let me write that properly. 2, hydrogen being equal to 5, and iodine being equal to 2 as well. Yeah, the numbers that I'm sure about are 0.5, 0.25, but when you see them, you'll be sure. Trust me, when you see them, you will be sure. So, yeah. So now we know the ratios. Back to this question. Now that we know the ratios, you can say carbon 1, you don't have to write the 1, hydrogen 3, and iodine 1. Or don't write the 1, just leave it like that. So this here is the empirical formula, right? If they wanted you to find the molecular formula, what they would do is tell you that the molecular mass is equal to some number, and you would find the empirical formula mass. So that would be 12 plus 1 times 3 for the hydrogen, plus I think it were 127 for iodine. That would be equal to 127 plus 3 plus 12, which is equal to 142. And let's say they give you the molecular formula mass to be 284 grams. You would put that over the empirical formula mass, which is 142, and that would give you 2. So then you would know that you should multiply all these species of the empirical formula by 2. So the molecular formula would be C2H6I2, right? Yeah, so that's how that's done. So let's take a look at example number 2. In this question, what you want to do is find the empirical formula first because that wasn't given. They just told you that 6 grams of a hydrocarbon consists of 4.80 grams of carbon and 1.20 grams of hydrogen. Of course, I'm going to skip the first step because we did that last time. So 4.80 grams of carbon. So 4.80 grams of carbon over 12 will give you the number of moles because it's the mass of the substance over the molar mass, and 1.20 grams of hydrogen over 1 would give you the number of moles of hydrogen. So let's do that quick workout. 4.80 over 12, that's equal to 0.4 moles, and this here is equal to 1.20 moles. Divide that by 0.4, 0.4, because 0.4 is the smallest, or the smaller of the two. So that would be carbon being 1 and hydrogen being let's check. 1.20 divided by the answer, hydrogen being 3. That means that the hydrocarbons empirical formula is CH3. Alright? And seeing that we know that, they told us that the molecular mass of the hydrocarbon is 30. And so we need to find the empirical formula mass. So that is 12 plus 1 gram, basically, times the 3 hydrogens, which would give you 15. So what you want to do is say molecular mass over the empirical mass. That is, what is it? 30 over 15, which is equal to 2. So that would tell you that in order to get the molecular formula, you will multiply the empirical formula units by 2. So that would mean that the molecular formula, let's scroll a bit, the molecular formula is CH3 twice, so that is C2H6. So that's how you do that one. Now let's take a quick look at worked example number 3. Okay, so this is a combustion analysis question. It says propane contains carbon and hydrogen only. 25 centimeter cube of propane reacts with exactly 125 centimeter cube of oxygen and 75 centimeter cube of carbon dioxide is formed. So deduce the molecular formula of propane and write a balanced equation for the reaction. Now let's deal with the balanced equation first, because that's what's gonna help us to get the molecular formula. So for now, let's write CXHY because we don't know the molecular formula for propane, plus oxygen gas reacts or burns to form CO2 gas and H2O liquid. Alright, so you have to add the water because water is a product of the combustion of a hydrocarbon. So the products when you burn a hydrocarbon in oxygen is carbon dioxide, or R, carbon dioxide and water. Now what else do we know? We know that 25 centimeter cube of propane reacts with exactly 125 centimeter cube of oxygen, and we got 75 centimeter cube of carbon dioxide. So now we want to work out the simplest volume ratio here, and what's common that can go into all three numbers is the 25. So you want to divide 25 by all of this. So 25 by 25, of course, centimeter cube, 25 centimeter cube, and this cancels this, and you would get 1 to say 125 divided by 25 is 5. This goes into it 5 times, right? So this here is 5, and here 75 divided by 25, that's 3. So you know that the ratio would be 3. So 1 to 5 to 3. What is this telling you? It's telling you that 1 mole of propane reacts with 5 moles of oxygen to produce 3 moles of carbon dioxide. Now the equation should be balanced. So if you have 3 carbons over here, you need 3 carbons over here, so that would make X3, so X is equal to 3. And if we have 10 oxygens over here, because 5 times 2 is 10, we need 10 oxygens over here, or 10 oxygen atoms over here, and we have 3 times 2 would be 6 oxygens right here, so 10 minus 6 is equal to 4, and so we need 4 oxygens, and seeing that there's only 1 oxygen on the water molecule, you could just multiply the entire thing by 4 to get 4 oxygens, and now we'd have 4 times 2 for hydrogen, which is 8 hydrogens, which would mean that Y is equal to 8. And so the hydrocarbon should be C3, propane. Propane's molecular formula should be C3H8. Now let's say you got the molecular formula as C6H2816. That's not possible. But the mole ratio was 2 to 5 to 3. What you would do is divide this entire species by 2, and you would get the C3H8. You don't see a lot of them like that, but in case you get one like that, you have to remember the mole ratio should be 1 to whatever. So you divide the hydrocarbon by 2 if you got something like that. But we know that the molecular formula for propane is, or alkanes, the general formula is H2N plus 2. In this case, N is 3, so C3H2 times 3 plus 2 is actually equal to 8, so you know that it's correct. So that's how you do the combustion analysis for worked example number 3. Let me know if you want me to do more of these. So yeah guys, until next time, drop a like on this video, please, and tell a friend about the classes held here on this channel every Sunday at 5:30. All right, I'll ensure that it premieres every Sunday at 5:30 p.m. That's Jamaican time. Yeah. So until next time guys, bye.